Rule. In this session, we'll see what cosine rule is, how to derive this rule for different types of triangles, along with that usage of cosine rule to find different elements of the triangle. In previous session, we have seen how to use sine rule. In that, the last question is left for practice. Now we'll see the solution for that question and then we'll get into the cosine rule. This is the problem given. Here we have two angles and then a line is drawn from A to side BC in such a way that it divides the BC in 1:3 ratio, and we have to find the ratio of sine of the angles. Now consider this triangle ABC. D divides BC internally in 1:3 ratio. So let us draw a line from A to BC. And now the D is located. Ratio here is 1:3. Let this be 1 and this side it's going to be 3. And given angle B is pi by 3, and then we have angle C to be pi by 2. Because of this AD line, the triangle was divided into two parts. The first one is triangle ABD. In this, if we apply the sine rule for sides AD and BD, we can write this to be AD upon sine angle ABD is equal to BD upon sine angle BAD. Now AD is equal to, take the sine to the other side, BT into sine angle ABD is given as pi by 3. We'll write that pi by 3 here upon sine angle BAD. Sine pi by 3, that is sine 60 degrees, which is root 3 upon 2 into BD upon sine angle BAD. Now for the second triangle, that is triangle ABC, again sine rule we can apply for AD side and DC side. AD upon sine angle ACD is equal to DC upon sine angle CAD. Again AD equal to DC into this sine will go to the other side, that is sine angle ACD. ACD is given to be pi upon 4 upon sine angle CAD. Sine pi by 4 is 45 degrees, so that would be 1 upon root 2. So this can be written as 1 upon root 2 DC upon sine angle CAD. We have two different expressions now. Here one expression for AD and then we have the second one. Equate both the expressions. What we can write this to be 3 root 3 upon 2 BD upon sine angle BAD is equal to, from the other side it is 1 upon root 2 DC upon sine angle CAD. Here we need to find angle BAD upon CAD. We have to just arrange this and we'll get root 3 upon 2 BD. Take the sine to the other side and take DC here. So we'll have upon DC and then root 2 to the other side will make root 2 is equal to sine BAD upon sine CAD. Now root 2 here 2, it would be root 2 times BD upon DC. The ratio is given to be 1:3. So this can be written as 1 upon 3 is equal to sine angle BAD upon sine angle CAD. Now here, so here 1 upon root 2 into root 3 is 1 upon root 6. That is the result here. This is equal to 1 upon root 6. Cosine rule. Cosine rule says that in a triangle ABC, A square is equal to B square plus C square minus 2BC cos A. Here when we are trying to find the value of A, we'll use the other two sides, that is B and C, and the included angle which is A. In similar way, we can find for B and C also, where small ABC represent the sides of the triangle and capital ABC are the angles. Now we'll derive this cosine rule for all types of triangles, and in each case we'll try to derive the second thing, the middle one, that is for b square. Now consider the acute angle triangle. In this case, just draw a perpendicular from vertex to the BC. Now we have two different triangles here. From the triangle ABD, cos B can be written as cos of angle is equal to adjacent upon hypotenuse. Here the adjacent side is BD upon hypotenuse is AB. But AB is nothing but C, so this can be written as BD upon C. On rearranging this, we'll get BD is equal to small c into cos B. Along with this, we'll apply the Pythagoras theorem as well. That is, hypotenuse square is equal to sum of squares of other two sides. So hypotenuse here is AB. AB square is equal to AD square plus BD square. Then AD square can be written as AB square minus BD square. Now let us get into the next triangle ADC. And this also, when we apply the Pythagoras theorem, AC square is equal to AD square plus DC square. But here this AD can be obtained from the previous equation. This is nothing but AB square minus BD square. And now from the triangle DC can be written as this overall length BC minus BD plus BC minus BD whole square. Expand this, that is AB square minus BD square is plus, this is like A minus B whole square, so BC square plus BD square minus 2 into BC into BD. Now this BD square and BD square will get cancelled out. AB square, AB is plus BC square minus 2BC BD. AB can also be written as small c. So this is small c square plus BC means small a square minus 2 into BC is again small a into BD. But here we have BD is equal to C cos B. We'll substitute that. So C square plus A square minus 2 into A into C into cos B. So here we have AC square on the other side. AC square can also be written as small b square. So small b square is equal to c square plus a square minus 2ac cos b. This is the cosine rule. Now in similar way, we can solve for a right angle triangle also. When we have a right angle triangle, as per the cosine rule, it is b square is equal to a square plus c square minus 2ac cos b. We'll take this right hand side and then prove that to be equal to the left hand side. So a square plus c square minus 2ac cos b. Here we have right angle at B, which means this will become cos 90 degrees. Cos 90 degrees is 0. So 2ac into 0, the entire time will become 0. Then we'll have a square plus c square. In a right angle triangle, we know that a square plus c square is equal to b square. Next is the obtuse angle triangle. In obtuse angle triangle, let us draw a perpendicular from A to BC again. When we draw it, it will look like this. So just extend BC to touch this line and mark this line to be D. Now consider triangle ADB. In this angle ABD can be written as 180 degrees minus angle ABC. Now in the same triangle, when we apply cos for angle ABD, it is nothing but adjacent side, that is BD upon hypotenuse here is AB. Now this AB can also be written as small c, which means that BD is equal to small c into cos angle ABD. But from the above equation, we can substitute the cos value to be cos of 180 degrees minus angles ABC. We know that cos of 180 degrees minus theta is minus cos theta. So this can be written as C into minus cos angle ABC. So BD is finally minus C into cos ABC can be simply written as angle B. Now in the same triangle, if we apply the Pythagoras theorem, AB square is equal to AD square plus BD square. On rearranging, we can write that AD square is equal to AB square minus BD square. Consider the second triangle we have, that is angle ADC. In this triangle ADC, we can write AC square is equal to AD square plus DC square, means again applying the Pythagoras theorem. But from here we can write the AD value to be AB square minus BD square. And from the triangle we can see that DC is nothing but DB plus BC. We'll substitute that here. That is DB plus BC whole square. Just expand this. We'll expand this with A plus B whole square formula, that is dB square plus BC square plus 2 dB into BC. Now this BD square and BD square can be cancelled out. AB can be written as small c and BC can be written as small a. And then we have 2 into dB. dB here, we have the value of dB, which is minus C cos B. We'll substitute that value, that is minus C into cos B. And again, this BC can be written as small a. This is AC square is equal to C square plus A square. This will become 2 into C into A into cos B. This AC can be simply written as B square. So from this we can write B square is equal to C square plus A square minus 2AC into cos B, which is the cosine formula. This cosine rule can be rearranged like this to obtain the angles when we know the length of different sides. So cos A is equal to B square plus C square minus A square by 2BC. We have just rearranged this. What we got previously is B square is equal to A square plus C square minus 2AC cos B, right? Now just take this to the other side and bring BC to this side. It will become 2AC cos B is equal to A square plus C square minus B square. Retain the cos B here, then we'll have cos B is equal to A square plus C square minus B square upon 2AC. This is the middle one. In similar way, when we calculate for all other angles, we'll get these formulas. We'll see how to apply these formulas to solve few problems. When we know two sides and the included angle, we can find the third side. Here is the example we have. Now we need to find A, means we have to consider the formula for A square. A square is equal to B square plus C square minus 2BC cos A. But here we have sin A. From this we can calculate cos A. This 3 by 5, and we know the combination 3, 4, 5 for the right angle triangle. When this 3 is opposite side and 5 is hypotenuse, 4 will become the adjacent side here. So cos A can be written as 4 upon 5. We'll use these values. B is 20 square plus C is 21 square minus 2 into 20 into 21 into cos A here is 4 upon 5. This is 400 plus 441. Here 5 is 4 times. 2 is 8. 8 into 4 is 32 into 21. We will get this to be 672. On simplifying this, we'll get 169 here. A square is equal to 169, which means that A is equal to 13. In this problem, they have given three sides here, and we need to find the greatest angle. To do this, we have to first find which one is the greatest side. On simple observation, we can know that this is the greatest one. Let this be A, and we have B and C. So the angle opposite to A would be capital A. Means we need to write the formula for A, that is cos A is equal to B square plus C square minus A square upon 2BC. Just substitute the values. B is 2x plus 1 whole square plus x square minus 1 whole square minus x square plus x plus 1 whole square upon 2 into 2x plus 1 into x square minus 1. This we just have to simplify. Expand the first one to be 4x square plus 4x plus 1. And for the second one, it is x power 4 plus 1 minus 2x square. And the last one, we can expand that and we will be able to write this cube minus 2x minus 2x square upon denominator also. If we multiply, it will become, just keep 2 outside and multiply the rest of the thing, that is 2x cube minus 2x plus x square minus 1. So here 1 and 1 will get cancelled out, x power 4, x power 4. And then we have 4x square here minus 2x square and then again minus 2x square. These will get cancelled. Now for x cube we have minus 2x cube. For x square we have minus x square and x term is 4x minus 2x is 2x and the constant 1. In the denominator we have 2x cube plus x square minus 2x minus 1. Let's take minus out. Then we'll have minus of 2x cube plus x square minus 2x minus 1 upon 2 into 2x cube plus x square minus 2x minus 1. These two will get cancelled and finally we have minus 1 upon 2 is the answer for this question. But then cos A is equal to minus 1 upon 2, which is nothing but, this is the value of cos of 180 degrees minus 60, that is 120 degrees. So the greatest angle here is A, which is 120 degrees. Coming to the next sum. Here we have angle C as 60 degrees and then we need to find this value. Just take LCM and multiply. We'll have B plus C into C plus A. Then A into C plus A is AC plus A square. Then B into B plus C is B square plus BC, which is equal to A square plus B square plus AC plus BC. Upon in the denominator we will have BC plus AB plus C square plus AC. From this equation, we can write A square plus B square is equal to C square plus 2AB cos C. We'll substitute this A square plus B square formula here. So then it will become C square plus 2AB cos C plus AC plus BC upon the denominator part, that is C square plus AB plus AC plus BC. I have just arranged the terms. Now here the C value is given to be 60 degrees. Cos 60 degrees is 1 upon 2 and then this 2 and this 2 will get cancelled out. Then we'll have C square plus AB plus AC plus BC upon C square plus AB plus AC plus BC. Both numerator and denominator are same. So this is equal to 1. Formulas of cos A, cos B, cos C, and simplify this. This is 2 upon A into cos A is B square plus C square minus A square upon 2BC. And then we have 1 by B into cos B is A square plus C square minus B square upon 2AC. Then we have 2 by C into cos C is A square plus B square minus C square upon 2AB. This is equal to, here if we take the LCM, it would be ABC. So we'll have A square plus B square upon ABC. Now in these terms also, if we see, we have 2ABC as LCM here. So we'll just multiply the numerators and write. Then we'll have 2B square plus 2C square minus 2A square plus A square plus C square minus B square plus 2a square plus 2b square minus 2c square upon 2abc is equal to a square plus b square upon abc. Now, this ABC and ABC on the two sides can be cancelled out. Here in the numerator, we can write 2b square minus b square and 2b square, that is 3b square. Then we have 2c square, c square and minus 2c square, that is c square, minus 2a square and a square and plus 2a square. This is a square. Now this denominator 2, if we take to the other side, it will become 2a square plus 2b square. And further simplifying, we can write this to be b square plus c square is equal to a square. So this is per Pythagoras theorem statement, which means the triangle is a right angle triangle with A as a hypotenuse, which that also implies that angle A is 90 degrees here. So with this, we have seen how to use the cosine rule in finding the elements of the triangles.